All right, here we are, the last set of notes for this chapter. So, short chapter, hooray! All right, so this set of notes is dealing with congruence and transformations. Okay, so this is the true definition of congruent. Two geometric figures are congruent if and only if there is a rigid transformation or a composition of rigid transformations that map one of the figures onto the other. And just a review, congruent figures have the same size and shape. So they look identical, and if you moved one and landed it right on top of the other one, they are congruent. All right, so example 1 said to name congruent shapes. So notice these two triangles are the exact same size and shape. But when you name them, you have to be careful. You have to, if I were to turn this triangle and land it right on top of this triangle, you have to name the letters in the same order that they line up. So triangle ABC would be congruent to triangle DEF. ABC, DEF. So those are called corresponding parts. A corresponds to D, B corresponds to E, C corresponds to F. Right, and then these two little triangles are congruent. And so I said triangle MKL is congruent to triangle UST, because if I did a reflection, then that's how they would land on top of each other. And if I just took this triangle and slid it straight down using a translation, this rectangle would land directly on top of this rectangle. So rectangle GHIJ is congruent to rectangle NPQR. All right, so example 2, we were given the original triangle JKL and the triangle MNP, and it said to describe a congruence transformation. So that means one or more transformations that would then land the original shape perfectly on top of the new shape. So what I chose to do is I did a translation to the right 5, which is the vector 5, 0, and then I reflected it across the x-axis. So this triangle would land exactly on top of this triangle. All right, so some of these combinations of transformations give us something interesting. So in this case, if I took this triangle and reflected it across line K, and then I reflected it again across line M, which is parallel to line K. If you look at the original shape and the final shape, notice it's actually a translation. And here's what's kind of cool is the distance between the lines is D. The distance from the original shape to the final shape is twice that. It is 2D. And we get a whole bunch of congruent stuff here. So looking at this example, we have this segment PQ that was reflected in A and then reflected in B. So it said to name congruent segments. Well, reflections are rigid transformations. So segment PQ is congruent to P prime Q prime and congruent to P double prime Q double prime. So those are all congruent. Reflections are always the same distance on either side. So right here, PJ is going to be congruent to JP prime. And again, reflections are the same distance on either side. So segment Q prime M is going to be congruent to segment MQ double prime. All right, now we're going to look at this, where if the distance is D, the total distance traveled is 2D. So part B says if the distance between the lines is 12, what's the distance from Q all the way to Q double prime? Well, 2 times 12 is 24. Part C says if we're going from P all the way to P double prime, if that distance is 25, what is the distance between the two lines? So this time instead of multiplying by 2, we have to divide by 2. The distance between the two lines is 12.5. Right, so this one is a similar one, except this time the two lines are not parallel. So we have line K and we have line M, and they're actually intersecting each other. So I'm going to take this original triangle, I'm going to reflect it across this line, and then I'm going to reflect it across the second line. And hopefully what you can notice here is it ends up being a rotation. And here the middle spot where the middle triangle is, the angle between the two lines is x, and it's almost identical to this one. The angle of rotation is 2x. So you're looking at example 4. A says describe the transformation that maps F onto F double prime. So it was reflected and reflected, but if we go straight from F to F double prime, it is a rotation, and 2 times 58 is a rotation of 116 degrees. So part B says, okay, what if the rotation from F to F double prime was actually not 116? What if it was actually 90? Then what would this middle angle be? It would not be 58. Well, the angle of rotation is double the angle between the lines. So 90 divided by 2, the angle between the lines would be 45. And that's our last set of notes for Unit 6A.